Tree plantations are an important component in the forest landscapes of the Mekong region. They are often established by smallholders to obtain land titles and create additional financial assets. The Finland-funded Forinfo project, implemented by RECOFTC, is working in the northern province of Bokeo in Lao PDR to demonstrate the sustainable utilization of smallholder teak. On the one hand, tree plantations were often established on steep slopes, with high risk of soil erosion and usually limited road access. This poses a great challenge for timber extraction, as costly road construction with potentially negative environmental impacts should be avoided. On the other hand, teak has been planted in the past close to roads and on land with irrigation potential. Here, timber production is under pressure by more profitable crops like rubber or banana. In order to avoid replacement pressure in the future, tree plantations need to be planted in locations where they do not compete with such crops. With difficult terrain conditions in mind, the Forinfo project introduced cable logging harvesting, combined with other forwarding alternatives at the hands of local communities addressing these issues. Besides manual downhill drifting and log chutes, cable logging is, in most steep slope situations, the only technical possibility to extract marketable timber in financially viable operations. Skyline, or cable logging, can be used for uphill and downhill extraction. Depending on the location of road access, the system is set up to harvest corridors on both sides of the cable line, at distances of about 30 to 50 meters. Maximum loads of about 1 ton can be extracted with such small systems demonstrated here. This film was produced during a first training session by Austrian instructors using the Maxwald Mini Skyline system in Bokeo province. Uphill extraction is technically the easier and safer system and requires only a single drum winch. The carriage is moved downhill by gravity. Cable logging systems use high-quality steel cables. In most cases, densified cables are used, which have greater strength compared to normal cables. The carrying cable can hold loads of up to 1,000 kilograms and has a minimum breaking strength of 15 tons. If logs are normally dragged on the ground by tractors or animals, the soil is compacted and the surface is damaged due to the plowing effect of the log end. By lifting one end off the ground or suspending the logs completely, cable logging offers a possibility to minimize damage to the soil surface and prevent erosion.
แสดงภาพในวิดีโอเนาะในการนำใช้สายสลิงขนาดน้อยเห็นว่ามีความเหมาะสมเนาะอยู่ในสภาพพื้นที่ของประเทศลาวโดยเฉพาะแม่นอยู่ภาคเหนือการตัดไม้นี่ที่ว่ามีความเสียหายที่สุดในการซักลากเนาะกกไม้น้อยล่มแล้วก็บรรดากิ่งไม้ต่างๆเนาะที่ว่ามีผลกระทบเนาะแล้วก็เฮ็ดให้กกไม้และสภาพพื้นที่หน้าดินมีการเซาะเจือนมีผลเสียหายหลายที่สุด
An inventory, marking and measuring the trees to be harvested, has to be carried out first, in order to assess the economic viability and plan the operation. In cable logging and harvesting operation, safety equipment must be worn. This consists of safety gloves, boots with steel caps, helmets with eye and ear protection, and cut protection safety pants and boots for the chainsaw operator. Cable logging requires a minimum slope of about 30%. In order to be economical, the minimum extraction volume in each corridor should be over 30 cubic meters. This means that either the effective extraction length in the corridor is maximized, or sidewise forwarding distances within the corridors are increased by felling trees toward the cable line, and pulling logs from the top end or using additional equipment as shown later. The small-scale extraction system, shown in this film, has a maximum extraction distance of 300 meters uphill and 200 meters downhill. Beginning with the setup of the system, instructors and workers decide the position of the tractor and winch. Walking downhill, following the proposed line of the main cable, workers mark the corridor between trees, establishing a straight line. The corridor is cleared from obstructing bushes. Strong trees for the intermediate cable supports are selected at distances of about 30 to 50 meters and marked separately. When positioning the tractor and winches, the distance to the first cable support, the angle of the main cable, and the anchoring point have to be considered. The Maxwell Mini cableway is shown here with a double drum winch, capable of uphill and downhill transport, and a wooden drum for the main cable. The system requires a tractor with a minimum engine capacity of 60 to 70 horsepower. The cable is pulled by hand from the wooden drum and carried behind the top anchor tree. It is then put into a block or pulley and lifted onto the support tree in upper slope position. The main cable is then pulled over the block downhill along the marked corridor by 1 or 2 workers. Different methods can be used to anchor the main cable line at both ends of the line. The cable is pulled around a strong tree or under roots which are exposed above ground. If necessary, end loops can be made in any steel cable as shown here. The cable is fastened with wire rope clips. The bottom plate of the clip should hold the section of cable where the pulling force is applied. The cable is then put through a snatch block or pulley and lifted about 3 meters up into a support tree. The main cable is fixed by a tensioning clamp or double block to a pulling cable with multiple turns in order to increase pulling power. A different option of clamping device is shown here. The pulling or transport cable is tightened slightly with the come-along hand winch. Textile slings, or if not available, steel cables, are positioned around strong branches or in forked stems on the selected support trees at about 4 to 5 meter height. The main cable is fixed with thin wires onto the top groove of the steel saddle. A rope is fixed to the support and it is pulled into position over a small pulley and fixed to the textile slings with a shackle. A second rope fixed to the support allows the adjustment of distance to the support tree and ensures the exact positioning of the main cable in a straight line between other supports. The carriage is placed onto the main cable while it is not yet under full tension. Tension is now applied to the main cable with the come-along hand winch. This will now lift the cable into its operating height with sufficient tension between all support trees. The main cable is fixed with clips around the anchor tree, and the pulling cable in the come-along winch is slightly released. The free running of the carriage, particularly over the supports, is tested. The deflection of the cable during this run indicates also the correct tension in the cable. Trees are felled following normal safety procedures, either towards or away from the cable line, with an angle of about 30 to 45 degrees. Trees can either be lifted at the top or bottom end, depending on the distance to the cable line. The log end is lifted and pulled towards the main line, and then uphill. Forwarding of logs by hand sulky, iron horse, or the mini crawler towards the main line will allow a wider extraction corridor and make cable extraction more economical. The effective corridor width can be increased to about 100 meters. Logs or whole trees arrive at the uphill landing point. The carriage is stopped by applying the brake on the pulling cable drum. The logs are lowered down to the ground. They can then be picked up by either tractor winches or loading cranes, depending on the site conditions and available road access. In many situations, extraction of logs to roadsides may only be possible in downhill operations. Paddy fields may offer extraction routes during the dry season. Setting up the cable logging system in uphill operation is very similar to the downhill operation. The system requires a second drum, which carries the pullback cable for the uphill return trip of the carriage. Pulling the cable manually can be very strenuous and is limited to around a 150-meter distance and lesser gradients. Beyond this distance, the cable must be pulled uphill by the pullback cable. This is laid out as a first step in setting up the downhill extraction. It has to be placed at least one full tree length away, parallel to the main cable. Most steps are similar to the uphill extraction system. Trees are again felled in the prescribed angle towards the main line. Extraction by hand sulky is much easier as compared to uphill situations.
Small cable logging systems like the one demonstrated in this film seem to present a cost-effective solution to utilize those forests sustainably and to cause as little as possible damage to the soil and with that future erosion.
Cable logging with small systems offers technically sound and economically viable extraction methods in mountain areas in the Mekong region. They open up new opportunities to establish tree plantations and manage natural forests in steep slope conditions.
If this system is eventually in place, smallholder farmers, small plantation owners will also then have the option to establish their plantations further away from roads. So it could create an incentive to utilize those lands in a more sustainable way through long-term use through plantations.